Hello again. This week's topic is environment management. It's a thing. You're a software developer, right? And before you get started on a project, before you write line 1, you need some kind of environment. I'm going to use web applications and PHP as an example here because I used to be a PHP developer. In order to build a PHP application, you're going to need a web server, a database, PHP, and then some various software packages to let all these things know about one another. All of these things need to be running and configured before you can build your application. Most web applications, at the very least, require that you have some kind of application server, some kind of database, and some method of communication between the two. So, for PHP, it's Apache and Mod PHP. For C#, you need IIS and .NET. For Java, you need Tomcat or WebLogic or one of the other Java application servers. For Python, you need a WSGI wrapper, so UWSGI or Apache and Mod WSGI, that sort of thing. So for the sake of this presentation, we're going to define your application's environment as the list of things that you need, aside from your code, to make a working product. In the case of a standard web application, your environment is composed of language, server, database, and libraries. But for a simpler app, your environment might just be compiler. So let's construct an imaginary project where the only person who knows how to set up the environment is the lead developer and maybe a system administrator. Now, this isn't a problem at first. The instructions for building your application are maybe to download 1 or 2 files and then run the code. Easy. But before long, the project has more dependencies, a larger environment, and then bad things start to happen. For example, a new developer joins the project. He needs to set up his computer so that he can work with your codebase. He checks out the codebase and, well, now what? In order to get to the point where he can do anything, the new developer needs to set up his environment. So he pages through the database, talks to the lead developer, consults online documentation, and generally dicks about until he has a mishmash of libraries and software packages that work well enough to get the code into an operable state. So now we have an inconsistent environment. It could be that each developer on your team is deploying against a different set of libraries, a different version of the application server, or a different build of the database. So they can check in something that works on their machine but breaks for everybody else. Or worse, it works on their machine but it doesn't work in production. And deployment can become very difficult. When it comes time to actually launch the software, nobody's really sure what the expected environment looks like. Once it gets deployed, none of the developers know how the live system differs from their development versions. And this is just for one project. Once a developer works on 3 or 4 different projects, they're likely to have 3 or 4 different environments installed on their development computer. It doesn't take long for that single computer to be running 2 servers, 3 databases, dozens of peripheral programs. It gets complicated, is what I'm saying. So let's talk about environment management. Now, the first scheme I'm going to present is just documentation. Simply write down all of your application's dependencies and instructions for installing and configuring them as part of the documentation included with the application. This is manual configuration management. Write good instructions and hope that your humans will execute the steps properly. And it makes a good dent in all of the problems that we've mentioned. New developers have a document to work from when they're setting up their environment. The project's libraries are consistent between developers, and deployment is much easier. So if you don't take anything else away from this presentation, take this away. At the very least, you need to document your environment. But there are pitfalls to stopping at just this. Oftentimes, this is very labor-intensive. As a software developer, you might spend your first few days on the job just configuring your environment. And again, if you ever change computers. System administrators also have to endure this entire process whenever they deploy their software. Let's talk about some of the labor-saving devices that developers have concocted to simplify environment management. Many languages have tools to help you organize libraries. Ruby has Ruby gems, Python has pip, C# has NuGet, Perl has cpan, PHP has nothing. Now, functionally, adult operating systems, here I mean most Linuxes, already provide package management on an operating system-wide scale. They're like app stores, except everything's free and you can use them from the command line. Type in apt-get install MySQL and, as if by magic, MySQL is installed on your machine. Package management is a thing of beauty. But while operating system level package management is useful for managing libraries, they're not available for every operating system and they're often limited as to what they can offer. A distributions repository has to keep track of the stable version of every major library for every language available on the operating system. Given the size of the problem, they do an amazing job, but if you're working with a specific language, that language often has its own repository and repository manager, offering more selection and more up-to-date packages. For example, Ruby's gem or Python's pip. With tools like this, you can include, with your source code, a list of libraries and fixed versions that are required to run the software. People checking out the project can point their package manager at this list and have the system configure itself. Of course, with tools that make installing specific sets of libraries as easy as running a command, you'll find yourself wondering how to run more than one application on the same system without inadvertently running over one dependency with another. Virtual environments provided by tools like virtualenv for Python or RVM for Ruby allow you to segregate environments into groups by application. This application has these libraries, and this application has these libraries, and never the twain shall meet. Many languages come with developer-friendly mini-environments that focus on creating a workable system for developers without all the trouble required to set up a complete environment. Visual Studio, for example, contains a complete server suitable for deploying IIS apps locally without having to run the entire IIS server stack. Django's run server comes with a built-in sample environment, as does Meteor.js. These developer environments have good qualities and bad qualities. They're easy to set up and they're consistent between developers, but there's a large gap between development and deployment environment. The actual details of your software's deployment environment are very opaque to your developers, which is okay if you're running the sort of devs versus sysadmins shop, where the devs think that the system administrators are bureaucratic Byzantine trolls who don't want to change anything, and the system administrators think that the devs are technology-addled attention deficits looking to bring down the company by introducing huge trees of poorly thought-out experimental dependencies. But there's some value to be had in forcing the two worlds, the worlds of developer and the worlds of deployment, to intersect more often. Mini environments often lean on light technologies that don't act like production technologies, like in-memory or on-file databases. And peripheral technologies, cachers, proxies, message servers, that sort of thing, often don't get consideration at all, forcing developers to manage an external environment anyways. Now, a combination of manual documentation, package management, and a developer mini environment will likely get you most of the way to operable and repeatable software environments. Lots of projects are done with some combination of these things. But there's more, so let's talk about virtual machines. The next few paragraphs here are wide generalizations, so forgive me. As a sort of ongoing trend, servers are getting more powerful and services are getting smaller. I mean, not less complicated, just more distributed. An infrastructure might be composed of a load balancer, web server, database, cache, file system, numerous services, and for the sake of scalability and availability, all of these might exist in parallel. While virtual machines come with an unavoidable overhead, they make managing this sort of large distributed infrastructure much easier. If the machine your service is running on can be scaled up or down based on demand, if it can be generated instantly when necessary and put away when it's no longer needed, you can maintain a very flexible server structure. With many more server deployments happening, DevOps noticed one of the fundamental rules of the universe. Provisioning servers is boring and repetitive, so they started building tools to automate that away. The tools evolved over time. They've become more complex to deal with the difficult problems of server provisioning, and they've moved from simple tools to run scripts on multiple machines simultaneously to full-stack frameworks for managing servers. All of that digression takes us to two more tools for environment management: virtual machines and automated deployment. Virtual machines are a great tool for environment management. Your environment can be completely captured as a virtual machine. If a developer needs to switch between projects with differing properties, all the developer needs to do is change virtual machines. New devs can download the VM snapshot and be handed a completely operational environment. This makes the environment easy to distribute, but it can be difficult to change, as a change would require you to redistribute the updated virtual machine to all devs. An environment management and deployment strategy built around VM snapshots can be extremely powerful, but requires a certain amount of finesse to get going smoothly. You'll need, at the very least, some kind of snapshot versioning scheme, or source control. But with environment automation frameworks like Chef, you can keep a snapshot of a vanilla operating system around, and then keep the environment's construction details as code in source control, right next to the rest of your code. Oh, and there's even a tool that automates the creation of blank VMs from the command line, Vagrant. It's pretty cool. Now, I'm not going to lie. When I started fiddling with Chef, I found it hard to get into. I like tools where I can jump in and be productive right away. Chef's documentation, while comprehensive, left me feeling like I had to read the entire thing before I could make any progress at all. So, just to get you to a hello world state, see if you can follow these steps. Create a vanilla Vagrant VM from an Ubuntu base box. In your Vagrant base directory, create a directory called Cookbooks. Inside it, create a directory called Hello World. Inside that, create a directory called Recipes. And inside that, create a file, default.rb. Tell Vagrant to use Chef Solo to configure the VM. Point it at your newly created Cookbooks directory and add the recipe Hello World. In the default.rb file that you've created, use the package resource to install a package, use the directory resource to create a directory, and use an execute resource to run an arbitrary shell command. The list of resources is available in the Chef documentation, and recipes and resources are really the meat of Chef programming. If you can do these things, you're probably far enough along to start exploring the features and functionality that Chef and Vagrant have to offer. There's a lot of good stuff in there, even if the cutesy naming conventions in Chef make you wince a little. So, I've introduced 5 different tools for environment management: documentation, package management, developer mini-environments, virtual machines, and automated configuration. Choose a configuration that's right for you. Have fun. And comment. Feedback is good. And that's the presentation. Thanks for watching.